Hello everyone, welcome back to our channel. Today video I want to show you how you can design low current triggered relay using 2N3904 transistor. So somebody have the problem for how can I controlling high voltage or how can I controlling AC by using Arduino. So the only solution is this one, right? The solution is using relay. So because you can using relay for controlled by your Arduino or any AC, anything, any low current or a low power by controlling high power. Like you need to controlling the AC ramp, but you need to control it by using Arduino. Like IoT, like you want controlling turn on AC motor using your Arduino. It's very used in the IoT project. So how you can do it? You need to know how you can using relay. So on this project, I feel like how can I make relay? So like okay, this one, you see, normally it's like switch. The one I using this transistor, you know the function of transistor, the first one is switch, right? So that's why like I using this to relay and the diode and the resistor for the protection. That's it. And then like here is the DCA, DC plus. This one is working from 5 voltage up to 12 voltage. Any supply voltage, it's kind of working. Even you can plug in on the PC USB. It's okay, no big deal. So I try to make the schematic diagram, and then I make the PCB, and then I make the 3D model. So let me show you everything. So like if you don't know how can you get this one, like you see when you press here, let me open. I need to show you the name of this ray I was using. You see the stronger ray just for 12 voltage. If you need to know more about this ray, see when you check here, see how it look like on the bottom side, top side. So if you need to know more, you can read this data sheet. This data sheet show us the name of company, the how you can connect it, the name of pin. You see this one. Sometimes the component is from Chinese company, so you see even this one is the Chinese devices. That's why you see everything's Chinese. So but sometimes you don't need to know everything, but like you need to know the size, the size, the size, just because you need to know how my PCB uh, can be dimensioned. So you need to know the size of your PCB. So like sometimes you need like okay, it's depending on the space, because sometimes when you make the PCB like one day I have the job and then they ask me what is the size of the PCB, what is the length, what is the width. So you need to know. And then if you have the long space, you need to know the which layer you have to use. So that's why you have the lexicon. So even sometime um, you need to have the translator for this Chinese, because you need to understand everything. So like this one is working for AC until 250 AC, and the current is this one, and this the power. So and you see the resistor is this one, the resistor inside. So the sometimes for me, because I'm a little familiar with the Chinese, something like that. So, but don't worry, I don't need to translate it. And the second thing that like I was telling you, it's working on the 5 voltage, 6 voltage, 9 volt, 12 voltage, everything it's working. It can working normally. So I show you this one, and the second component you have to know the how is the specification for this one is what. Okay, I think you need to know the specification of this transistor because sometimes you know the company they have different function, so you have to understand everything. So the normally is on even this transistor you see is smart is surface hole is smart surface mode. I don't need on this time for me when I make the PCB I don't like to use 2-4 because I see the 2-4 it's I don't know for me I think though it don't look well, so the why like see nice this one is English one nice. So is a general purpose application is switching application. You know the general purpose for this transistor we use is for switching. That's why we use for this one because the function for relay is normally switch is a switch, but it is a switch supplied by low voltage and then controlling high voltage. I think you understand the function of relay, right? Mhm. The second thing, okay, let me show you another thing. This, this one it show us everything, how can be connected. If you don't know how connecting this one, you can check here because they tell you time drain, time rising, storage time, full time. You can take this one, you can connect it like this one. So because they give us the reference for switching time, the switching time they give us the reference semantic diagram because some people they asking me how you know which resistor you have to use. So okay, because the manufacturer when they make these devices they make the reference. So like when they tell you the 10, even you have make the simulation before make up printing this one before applicable you have to make the reference. You can make simulation. You can using some software for making the simulation first, because you don't go take a copyright 100%. No need to make copy paste 100%. You have to think about on it. Like here they putting this capacitor, but this capacitor you see they putting dash, meaning this capacitor is not official put in there, but sometimes the capacitor used for coupling. Sometimes you don't know if you have the some AC current inside, but you need to check if this one, because if there is some AC current, if the voltage is not the current is not the total DC, you have to use this capacitor for coupling, for removing all AC and then continue all DC. So you have to make the simulation before. The second thing you have to understand on this one. Just as I told you before, you have to know the size. Okay, when you look at this table, let me show you clearly. You see, they show us like A, A is like is width for this one is this one is mir. You can converting the mir. So if you don't know how to know the mir, just you can take copy 2.9, then you go to the Google, it's like mir to AM. You see, they gave us in the mir. This one is millimeter, right? This one is millimeter. Okay, this one nice. This one is a millimeter, 2.9. It means 0.29 centimeters. So just right. So you have to know what is the weight of it. It's this one, the P, what the favorite header on the pin. So the pin can know the size of pin. It's this one. So you have to understand everything. Um, And the second thing you have to know, I think here you understanding the function of everything. So like here is the you connecting something you have to control, right? So here we're putting the red here, right? And then put like AC. If you're connecting the AC red here, for example, you have to connecting something here. Suppose that I'm putting light, just this one. Now you see it's open because this 5 and 6 is normal open, but then you have to switch. So when the current come on this one, you see, when the input is available, you see what is it? This one it's open switch, and then when this one is there is current here, it's pass on this one because this one is forward resistor. When the current is this one is come from here, it cannot work in the reverse. So when this input is available, the Y is working in the forward. When the inside of this relay, there is coil. When this coil be charged, they can switching this one, and then power crossing on this one. That's why. So you see this power, this switch is turned by the charging of this inductor, but there is no connection between this one and this one. That's why this inductor is be charged by low current, low voltage, and then help us to turn on high voltage or high current. That way you can using DC voltage to controlling the switch, to controlling the AC voltage. I think right now you understanding the logic behind of array, right? So the second thing I will have to show you is the PCB. I tried to make the PCB for the single side because this one mm, uh, it's not complex PCB design. So the why I chose to use the single one because it's not big. Um, yeah, you see, only one side. I connecting everything on the top layer because I say like nothing special. Yeah, it's like you see, but this one, this N, this N is supposed to be ground, right? For me, this N is supposed to be ground. When you look here, like in the schematic diagram, this one is supposed to be ground. So if I want, I can put the ground on the copper, like go here, choose triangle. Remember, I'm on the button layer, and then I choosing NC net. NC, just NC is the ground for me. Right? So no, okay. See, it's actually film layer. Film layer is not what I want. Just I want copper layer, right? So and then you see it's felt nice. We build the copper layer. You see, like very nice. You see now it's so good. And then like let me show you the difference. Look here, this 3D model, this is array, this is a switch, this is our header, this is our component. Of course it's a few. You see work like how it look like. It's look nice, of course. Huh? And then like let me check, let me do this one. You see it is same, but when you look on the button, it somehow changed because I put in the ground, I put in the copper on the ground. Before there is no copper on the bottom side, but now there is copper. So I think you understanding the function of the relay and how relay is working, how you can make this high new array. So, uh, thank you for watching. Don't forget to subscribe to this channel. If you have any question, don't forget to drop in the comment section. I will reply you on time. Thank you. Bye bye.